So hero of the day, binary search tree. Fine. This one talk about mostly about hero, but without further ado, let's get into it. So hero. um, Trees per se, and then it's falling under the category binary search. And obvious, use brute force to actually fight against this hero. For spells wise, so right, I think it's important play out series to actually draw some inspirations. Cool. These are binary search tree. Find. So what we have here is that maybe say the liquid questions specific asks you I want to find the target for the 5 right. So cool. Like similarly to Z operation per se, where Z operation is talking about a lot of like a list of array per se, like they are being sorted out 3, 6, 9, 10. So it's obvious that for Z operation it's like an array that's been sorted. For trees, usually if this is like a Y operation per se, is that it's also been sorted in some sense. So what's gonna happen is that it's gonna like reiterate itself for every single node. So say this is 2 per se, the left side is always smaller, so it's gonna be 1s, and the right side always bigger, so that's a 3, and it's gonna reiterate itself for this node as well, right side to be bigger, so obviously a 4, and can point towards a null eventually. Cool. So now, you say that you try to find the target value per se is 5. What it's gonna do, if you're gonna see the first value per se, and if it's not the value, you ask that if it's like so you go right side, obvious is to say that it's increased per se, and left side is decreased, so obvious you go to the right side per se, it's sort of like increase, and same things, it's gonna like ask the question again, is it a plus or a minus? Obviously your target is a plus, go towards the right side, point towards here, same thing, ask the questions left or right, obviously you want to take the right one, but this time around it point towards a no, and you return back to the system as this, that you don't have the target value per se. So what we see over here is basically the payout series per se, and we can obviously say that the way that it maneuver around the map is based on conditions. So we constantly have like our tree is constantly casting the spell of like based on like the condition is all constantly asking these conditions before kind of moving and then move, and at the end of the day it's to actually find the targets efficiently. I mean, that is like the core objective for casting the spell for a tree that is of a binary search. So obvious, you're gonna use a brute force to actually argue against our hero, and this hero, I feel like this hero is a hero with no drop. No drop. It's just that the way it moves around the map is very elegant, it's very smooth. That's what I can tell, at least. And so if you were to actually do brute force per se, is that when you try to move around the map, it's just gonna move like this, and you're gonna move everything. So obviously, like the time operation per se for these operations, if this is the Y operations, it will take on like a big O of N per se. I think this is W operation where you kind of reiterate, but for Y operations, it obviously constantly trying to cut half for every single time it goes through a certain value. So most likely it's gonna take up on to like a big O of like log n operation per se, because it's like constantly cutting half, like constantly cutting half, constantly cutting half, you know. So that's the way that I think that I will try to argue against brute force against tree per se. But obviously they do talk about like what if say the tree, because this tree per se, they call this to be balanced, in a sense that the difference of here and here, I don't know what's the exact term, the right terminology to talk about this, but what they're saying is that if the difference between here and here is at least a 0 or 1s, maximum to be 1s per se, it's fine. It's called to be balance of a tree. But if not, if there's like a, imagine like this value don't even exist at all, it's obviously like some sort of like unbalanced tree per se, and it's gonna big O of operation, it's not gonna be big O of log n anymore. I believe it's gonna be much more, and at worst case I think it will become n's, but we're talking most of the time where Y operation, where it is like considered to be a balanced tree per se, then it will obey the law to big O of log n time complexity, and it can actually be only a balanced tree will be able to fight against this brute force per se. So yeah, I think with that everything comes to an end.